Hello and welcome to this Edexcel GCSE Geography topic overview looking at UK landscapes, and for this one we shall be looking at rivers. So I'm just going to scroll through to the correct starting page. This is just a short review of the key information from the topic. It is not everything that you need to know, but you can look at this along with your class notes and revision guides and your own revision notes just to make sure you've got the key information, but you will need to add detail to these. Feel free to have a go at making your own after you've watched this as part of your own revision, or even have a go at making a video. Now, as always, it's important when we're revising to have a look at the specification to remind ourselves of what the exam board want us to know. And we can see here the key information of the different processes that interact to create the river landscapes, the fact that erosion and deposition are some of the key features, the human activities, and then also looking at a case study and examples of these. So one thing that I always like to do is to produce a little mind map. And here you can see this is a mind map for all of the UK landscape section. So over here we have the UK landscapes overview looking at geology. We have the river section over here, and we have the coast section here. You'll also notice this section in the middle, and these are the processes because these apply mostly to both rivers and to coast. So rather than repeating the revision, I've put it in the middle there. So let's have a look at rivers in more detail then. So we're going to look at the key processes. Now again, these work for rivers and coasts, so we'll have a look at them. So the main processes we need to understand, first of all, the first one is erosion. This is the wearing away of the land. And we have the main types: hydraulic action, the force of water getting in; abrasion, the water using material and rocks to rub against the riverbed and riverbanks. We have attrition, which is where the rocks and material bash against each other, making them smaller. And then we have solution, which is where some of the particles are dissolved into the water. Now other processes is we have weathering. Now this is different to erosion, is because this is the weakening of the rock in situ, or where it is. Okay, so it doesn't move it, doesn't make it disappear, it just weakens the rock. And weathering can help erosion take place later on. So we've got the main types. We have biological weathering. These are the plants and the animals growing roots or burrowing into the rock and soil, weakening it. We have chemical. This could be things like acids in the water, or if the rocks are alkali, and it can lead to some of the rocks dissolving away. We also then have mechanical. Now these can be processes such as freeze-thaw, where the water gets into rock, it freezes, expands, and starts to break the rock apart. You can also have things like exfoliation, where the outer layer of the rock heat up, but because it doesn't expand or it doesn't move very much, it can cause cracks within the rock. Now both erosion and weathering can be greatly affected by the weather and climate. Okay, if you've got heavy rainfall, that might lead to more water in the river, leading to greater rates of erosion and also greater rates of chemical weathering. If you've got a climate where there are extremes of temperature, this will have a big impact on mechanical weathering. The weather and climate can also have an impact on the plants and animals, which also might affect biological weathering as well. So it is important to look at the links between weather and climate and how they can affect erosion and weathering. Then we have transportation. Now transportation is the movement of material. Now this might be by traction, which is the rolling of the largest material; saltation, this is the bouncing of smaller material; some load might be so small that it can actually float and be suspended; and then we have the solute load. This is the material that has dissolved into it. Now we'll ignore longshore drift because that is just for coast for this one. Now When the rivers lose energy, they can no longer transport the material. Therefore, they deposit it. So the material will sit on the bottom of the riverbed and start to build up. And this becomes very important for processes such as meanders, oxbow lakes, floodplains, and levees. And then finally, another main process is mass movement. Okay, two main types: sliding, where material just slides down, or slumping, where whole valley sides or cliff shapes can just slump in one whole movement down there. Now again, mass movement can be increased when there is weathering, so the rock has been weakened. The weather and climate, heavy rain can have a big impact if it gets into loose soils, and erosion at the base of cliffs and valleys can also mean it has no support, which may encourage more mass movement. So you can see all of these processes are linked together. Now, when we look at rivers, we know there are key features, and the rivers change from the upper course to the lower course. In the upper course of the river, this is the high land. It has high levels of rainfall, and it tends to be, because it's high, the main erosion type is vertical. It's cutting down into the land, and this can lead to features such as V-shaped valleys and interlocking spurs. Where you sometimes get hard rock on top of softer rock, it can lead to the softer rock eroding more rapidly, leaving an overhang which then collapses, making the waterfall, and as it retreats further upstream, it can leave a steep-sided valley called a gorge behind it. Now, if you link this into the UK landscapes, because it's high land, the main land use around it is for recreation and forestry. So we move down into the middle course, we have both vertical and sideways or lateral erosion. This means that we can get meanders or bends forming on the valley floors, and these meanders help to widen the valley floors. Now, these wider valley floors can sometimes be used for crops, and the valley sides, the steeper valley sides, are used for sheep farming. As we get lower down the river into the lower course, because it's nearly at sea level, lateral erosion is the main form. And we do start to see more meanders, and we also get oxbow lakes. Now, when the meander necks, the erosion on the outside of the bend, because the river is flowing more rapidly, mean that the neck of the meander start to join together. And over time, this can cut the meander off from the main river, leaving an oxbow lake behind. So on the outside of the bend, you've got faster travel of water, leading to greater rates of erosion, leading to river cliffs. On the inside of the bend, however, the river travelling much slower, it has less energy, forming landforms such as point bars or slip-off slopes where you have the material. So on the inside of the bend, it tends to be very shallow until it gets deeper into the middle and the far side of it. Now also, you can have depositional landforms of floodplains and levees. Now these are formed when the rivers flood. When there gets too much water in the river, it can no longer be contained by its channel, and the water goes over the sides. Now, as soon as the water leaves its channel, it starts to lose energy and drops big material at the side of it. The biggest material gets dropped first, and over time, these can form these natural embankments called levees. The smaller material gets carried further over the floodplain, depositing small silt and soil over the rest of the valley floor. Now this can lead to sort of good fertile soil, and gradually the level of the floodplain can build up over time with different layers from flood events. Now it's also important to remember the Bradshaw model, and this is how various different factors change from the upper to the lower course, and this also links in to your rivers fieldwork, because we looked at how the rivers change from upper to lower course. The gradient of the river, the angle at which it slopes down, reduces as you move to the lower course. The width of the valley increases as you get to the lower course, and the river depth, the width, the speed of it, and the amount of water of the river also increases as you move to the lower course. The sediment size the material that carries gets smaller as you go down the river because of the erosion, the attrition taking place, knocking the rocks together, making the sediment smaller and smoother. We then look at the human side of things. And the key factor when we're considering with humans is issues around flooding. We need to know what are the physical causes of flooding, such as heavy rainfall, shallow soils, and it may be steep slopes, encouraging the speed of surface runoff and reducing interception. We also then have human factors, such as chopping down the trees or building settlements and roads, which means the water can't sink into the ground and increases surface runoff, and so the amount of water in a river increases. We need to know the brief effects on people of flooding, such as people losing houses, so becoming homeless, and the cost to repair, the cost to businesses, and the environmental damage from pollution and damage to landscapes. We also need to look at how flooding can be managed. And we look at two main types. We look at hard engineering, which is trying to beat nature, building dams and reservoirs to store and control the flow of water, and creating wider, straighter channels to mean that the water flows more rapidly through the river and so isn't able to flood because it's travelling to the sea quicker. We then look at soft engineering, which includes things such as land use zoning. Now this is where on the low-lying land next to the river you would have land uses which aren't affected by flooding much. So you might have cattle farming because the cattle can be moved off, or you might have sports pitches which can easily be repaired. Then as you move further up you then might have roads and rail links, because although the roads might get damaged you can actually move the valuable cars and things off them. Then you could have industry, and on the highest land you have housing to reduce the amount of social effects. The other thing you can do is something called washlands, where you allow certain areas of land to actually flood. This takes up some of the water and prevents it from flooding other areas lower downstream. So it's like storing the water in areas which aren't as important as others. Now, just to help you, just in case you're not sure, one of the key things you need is a sort of a case study, and one that's in the textbooks and in the revision guide is the River Dee that starts in North Wales, flows through Chester and then out into the Irish Sea. And you can see you've got the key information here, the long profile diagram, a bit of a similar to the Bradshaw model, and then some of the key information. But it also links it to the different types of land use in the upper, middle and lower course, and this also links into UK landscapes. So I hope you found that useful. There's a lot of information there. If we go back to the overall mind map, but my computer's crashed so we won't see that, but have a look back over that, compare it to your notes and make sure you've got all the information. So I hope you found that useful. Thanks for watching. Please check out other videos in the series and see you soon. Cheers. Bye.